Thank you all for being here. Welcome for joining us, and thank you for your patience. We have a power packed jam session today in the fast evolving era of generative AI and autonomous agents. Organizations face a double challenge harnessing the power of intelligent systems while maintaining control, accountability, and trust. Today's session brings together cybersecurity, leadership, AI expertise, and hands on experiences to explore how AI agents can be governed responsibly without slowing down innovation. We'll focus on practical frameworks, architectural designs, and real world lessons for moving agents into production securely and confidently. So let's start with some foundational questions that come up again and again with teams as they move from experimentation to production. So I want to give this question to everyone, and we're going to kick it off with you, Josh. Where should control logic actually live in a production ready AI agent systems? Many teams try to keep agents on tracks using prompts or instructions alone, but this approach often breaks down as systems become more autonomous. So I'd like to hear from you first and everyone else about your perspectives on where control should live technically, organizationally, or in today's world, both.
Oh man, we could talk about that the whole time. No, I appreciate it. Hi everyone. I recognize some of the folks on the call. Who can I shout out to? I saw Tony. I saw Rich. Anyways, if I know you, hello. My name is Josh. Just to give Josh Devin, just a quick background. I am the co-founder and CEO of a company called Sundera. We're focused on like building the agent behavioral like guardrails. How do we put deterministic controls like around these agents? So Melissa, your question is like spot on and like dear to my heart. I think what we're seeing is like, I think a lot of folks are what I call like prompt and pray, right? Like we try to use controls like in the system prompt, and we say things like, you must never and you must always and do this and do that. And if we put it in capital letters, we really mean it. But as we know, I think like trying to control agents at the prompt doesn't work, right? Because even if they're not prompt injected, they can have misalignment. And I think that's another area where teams go wrong when it comes to like, where does control need to live? Like it can't live in the prompt, right? Because the prompt is susceptible to, non-determinism, right? So we can't use that as a firm control. Please stop at every red light. Doesn't work in a prompt for us, right? The other challenge I think that folks see is that like we think about controls only in terms of like stopping a bad thing. Um, uh, but I think the challenge with agents is that because you, rather than just being like malicious, you have a hyper competent, like super helpful assistant. So if you tell it to do something, it might like brute force the logic space and achieve something in a way that you didn't anticipate, which could have deleterious or like negative effects. And so, I think like thinking about how do we, control the agents, not just from a stopping and doing bad things, but they might just, go off and like do a thing that we didn't expect them to do, because they're sycophantic. And then I also think there's a challenge, and then I'm going to shut up and let others talk. I also think there's a challenge on like where folks go wrong, where I see folks struggle in the enterprise where it's like someone has an idea, let's build this agent. And then they try to, figure out where the controls need to live. And they do that by, we all get in a room, let's think about all the risks that this agent might do. And that's really difficult. So I think control really needs to begin like shifting left as much as possible in terms of like simulation and understanding like what can go wrong so you can understand what controls, you really need. So, um, uh, you know, I guess like as a metaphor, it's sort of like, right now we're putting like the speed limits in the car, like in the instruction manual, and saying like you're not allowed to go over 55 miles an hour, but that's not a hard rule. We need to figure out how to put controls deterministically outside of the agent that stop behavior that we don't want to occur. Sujan, Manjit, love to, or Melissa, take it
Yeah,
however you want to.
Sujan,
But
that's a great like segue into I think your thought.
Sure. I'll start with the technical and then focus on the organizational. Hi, everyone. Thank you so much for your patience. So, in terms of technical, I tend to approach this like traditional software engineering. We shouldn't be throwing away everything we've learned over the last 50 years. Sort of workflow and state machine orchestration, understanding your allowed states, transitions, your retries, your fallbacks. It's really important to be able to map out most of your logic the way we've always done, be able to test that, define it, understand the inputs and outputs. And people talk a lot about autonomy, but I tend to treat LLMs as things you use on the edges initially for extracting information, summarizing, intent classification, and on the other edge for presenting information back, not necessarily for autonomous decision making. I'll get into that, but I think you start with a deterministic state machine and you use LLMs on the edges. And that's a good place to kind of start at where you can still reason a lot about different things. Then, what we're seeing more in the industry now is like policy as code. We're used to writing IAM kind of policies for Amazon or Azure or cloud. We can kind of take that further and be able to write policies for agents and have those policies be executable so you can actually check whether something should happen or not happen and what outcome it may have. And then based off of that, should we allow it? So it's sort of automating some of that policy driven check and turning that into code so that those checks, pre and post checks, can happen before the agent and after the agent does something. And then finally, just like kind of like runtime sandboxing, least privilege kind of permissions and observability or lineage. So having a safe environment to run these in, restricting access to what it can do on a machine or in a VM or a container in the cloud, and then the lineage of what did the agent do? What did the human do? What action did it take? What record did it update? What decision did it make? And being able to trace that all the way through. So you're not just auditing what happened, but you need to be able to answer the question of why did it do that? From an organizational perspective, I'm going to kind of go pie in the sky here. It's a little bit thought experiment, and then I'll hand it over to Majid. Think of your agent and your agents as personas. They're named accountable owners. Understanding what their set of responsibilities are. Imagine you gave an agent an employee handbook. Read this handbook. This is what you're allowed to do and what you're not allowed to do. Having that along paired with on the behalf of a user or a human user. So, in terms of like the 3 pillars of observability, when you're logging something out, you're going to have a human ID, right? User ID, some actual principal that's human based, and an agent ID that's artificial based. So you can track what happened, who it happened on behalf of, so you can tie it back to accountability.
Manjeet.
Thanks, Melissa. Hello, everyone. I'm the founder and CEO of Droopstar. We are providing cybersecurity in regulated industries such as gaming and healthcare. Thanks, Melissa, for that question. Really, I view this situation as not really about control. It's really more about operating these agents with confidence. And that's what it really comes down to. In a regulated environment, we should view these agents just like, operational and authorized actors, just like Sujan was just now mentioning. And so you want to treat these agents as critical infrastructure, not a software feature. Another point that Sujan very eloquently mentioned. And, how do you do that is really the fundamental question that we come to. The first thing one needs to do is really understand the risk around deploying a new agent. What does it mean? What does it do? Understanding the parameters around that. And once you have an understanding about the risk profile of this agent that you're deploying in production, for the sake of this discussion, I'm going to assume that we're talking about a live environment, not a test environment. And so in a production environment, you want to establish guardrails. And the guardrails cut across 4 layers. The first one is really about, having a governance, understanding, what it's authorized to do, what it's responsible for, etc. Have a racy metrics around the work that this agent will be doing. Also understand, where a human might come into the loop in the agent's operation, whether the human is on the loop or in the loop, right? So that's all part of the governance guardrails that one needs to put together. And then the next layers are really technical data and operations. What we mean by technical are the things that Sujan was just talking about, prompt constraints, privileges, accesses, runtime controls, etc. On the data layer, you're looking at classifying the data that's going to be used by the agent, and tagging the data, understanding what data can be exposed to the users of the agent and what may not be, where data masking might be needed. And the other element on data is, some of these agents are able to work across multiple tenants. So what's the cross-tenant learning aspect of it? So, there needs to be a good understanding of the guardrails around data. And the next one, and the last one in my category here, is operational, and that's to understand what's the model risk, what's the drift and bias assessment that you need to perform on this as this agent is operating. And last but definitely not least is incident response. When things go wrong, what are you going to do about it? And so having an incident response about it. If it's a critical response incident, you got to do the following. If it's a medium level, you need to do the following, etc. So having those ready ahead of time, thinking about that. So that's kind of how you prepare to get an agent up and running in a production environment with confidence.
Yeah, thank you all for that perspective. Josh, I want to kind of pull the onion back a little more and get your perspective, and maybe starting with AI systems and the reliability standpoint. Where do you see teams going wrong, and where does real control need to live within these systems to work in production? The key word being control.
Yeah, I mean, I think we kind of like talked a little bit about it, and I echo what Sujan and Menji just sort of said, and like the fundamental challenge, right, is like how do you govern something that's non-deterministic, right? And the way that we do it today, right, with human beings, right, is we assume that humans are prompt injectable, they're going to be fished. I'm allowed by the First Amendment to tell you all to do all terrible things right now. I can give you links on Reddit that will tell you to do terrible things, right? And I'm allowed to. And we have to assume that someone's going to read that stuff and decide like, that's a good idea. So what we do like with humans is we don't try to do mind control. I can't control what you read. I can't control that you are, you might get phished. And so what we do is we put behavioral controls around humans, right? We lock doors. We have key cards. When we're, if Sujin and I are going to launch the nukes, we got to do the key turn at the same time, right? Like, so we put in these barriers to bad ideas in the enterprise, and it's a tricky thing because like we celebrate non-determinism as humans, right? We have a First Amendment. We tell people think outside the box, break all the rules, don't do anything like before, right? So we want that non-determinism, and I think that's the beauty of an agent. The challenge is that we have. I would argue one might argue, right, that all civilization, religion, everything is really everything that we do is built to handle our non-determinism, right? Um, and so we don't have that same pattern yet with our agents, and that's what when we talk about control, what we need to build. We need to assume that the agent is always prompt injected, assume that I can't go back to the model maker and be like, oh, Google, I don't like the way Gemini, is doing X, Y, and Z. Can you retrain the model for me? Or there's something bad happens with the model. Are you going to shut down all your agents that day? If you're running 100,000 agents, like what do you do? Right? Like, so the controls really have to be on the outside of the agent. and be observing agent behavior. And then to Sujin's point, like, the approach that we're taking, right, is like we use policy as code to evaluate the agent's behavior in real time. And then if it does something that goes against a policy that has been generated, we stop the behavior or steer it. Hey, you're not allowed to do. And so that to me is, Manjit, like what you were saying, like how do we get like these trustworthy agents? To me, it's two components: reliability. Like, do I know that the agent, is the Waymo going to get me to the airport most of the time? And then it's all governance. Does it get me there without running over 17 people? Right. And it can reliably get me to the airport by running over 17 people, but that's not the way that I want it to. So creating those bounded controls is tricky and needs to be done constantly at scale, because another difference between humans and agents is that agents can instantly learn more and do new things. And when a new model comes out and it's suddenly able to do programmatic tool calls and build, tools on the fly that don't even exist yet, or other agents that don't exist yet, we need to be able to have controls around ephemeral, things like that. So I'm kind of like, digging up a bunch of the onion layers here, but ultimately behavioral controls is where it's at, in order to stop bad things happening. And there's a defense in depth strategy here too. I think, the last thing I'll say is like, we say in security, right? Like we have two mantras, right? Like, we say assume breach, like assume you're already breached. How would you do your cybersecurity? I think with agents, it's like assume they're prompt injected. How would you do your security? And then the other is we have a principle of like least privilege with humans, right? Like I only give you the access that you need to do the thing that you need, right? But with agents, it's a little bit different. It's principle of least autonomy. How do we continue to constrict the autonomy while still maximizing the value that we get from the agent? I only want the Waymo to be able to drive on the streets. I need to restrict its autonomy while still giving it the unbounded non-determinism to find the best way to the airport. And that's kind of a never-ending game as these agents get new capabilities. And so it's really about how do we translate, the 10 commandments into policy as code for every agent. Like we probably all want policies like don't steal for every agent. Every agent can steal differently. And I can't generate ahead of time a list of every way to steal, right? So that's the tricky part here. And that's a lot of like the work that we're doing. And so Melissa, I hope I just added to the conversation.
No, I
Like,
think great perspectives. And I like the examples. I think it gives people, something to visualize in their head. And so it kind of ties into what I want to ask Manjeet. Now, you have a deep expertise in technology, leadership, data security, cybersecurity. And I know I want to get your perspective on how you think about control when AI agents are operating, like you mentioned, kind of in high risk or regulated environments like a casino. What expectations should CEOs and executives have about these guardrails and how governance should really be enforced?
Yeah. I view the whole idea about controls here is to really give confidence to the executives around deploying this new technology. And as you know, effective governance really should build trust, and it's really about trust. And so, really, when faced with challenging things, it's always helpful to go back to the core principles. And core principles are to understand what is it that we are really aiming to do with this new piece of technology? What's really the value that the executives are going to get if we are able to articulate that to a CEO or CFO. I think we'll have more success in gaining their trust. And so to be able to articulate that is the fundamental thing. And then the other question that most executives will wonder about is, what's the risk of doing this? What's the cost and the risk of doing this? And and one needs to be able to address that. And the follow up to the question around risk is, how are we going to control the risk? And in the world of cybersecurity or running any business, you're looking, you want to push as fast as you can. Josh was very eloquent in saying that, you want to give it as much power as you want, as you need, However, at the same time, you do need to control your risk, right? So that's what you're really about. So understanding the risk and what's the risk mitigation plan. And I talked earlier about the four layers of controls one can have: governance, data, technical, and operational, which have actually been covered by colleagues in some detail here. And so that's kind of really to build trust about any new technology. One needs to be able to articulate the value and then also have a risk mitigation plan around that.
Yeah, great points, Manjeet. Now, Sujan, as a fellow engineer, I always find it great to want to design something, and then you have to really put it into implementation. It's a whole nother ball game, and so let's bring this down to implementation. How does this translate into real systems design, and where do engineers need to move control out of prompts and into architecture so autonomy doesn't turn into unpredictability?
Awesome, thank you. And this kind of builds on the last question and the answer. And a lot of it again has to do with traditional software engineering and security practices. So like as an organization today, if you were to evaluate yourself, where would you be on that DevSecOps spectrum? These are all things that we should be doing anyway. So I tend to look at it as a sort of layered architecture, reducing your blast radius. So you have a layered architecture, you delegate certain responsibility to the layer below, certain things you do above. You only allow things, a limited number of things to happen at each layer. So if you have that layered architecture and delegation, and you have that in a way where your application level set of business rules, actions, and logic is controlled, right? That's the application layer. There's also kind of the host cloud layer where you're talking about network ingress and egress and IAM and things like that, and the permissions and restrictions around that. You have the resource level layer as well, your file system, your processes. So where does control live at each layer? What are you allowed to do and not allowed to do? What should be delegated above or below, depending on what action is occurring? So that sort of architecture and design is something that should be part of any software stack, right? Not necessarily just AI or agent driven, but it becomes extra important when there's level of non-determinism added to your software. So I still approach it the same way. And then in the last question, I kind of touched on state machines, right? So understanding that's a combinatorial problem that goes back to quality assurance and testing. What are all the states your software can be in, right? And so knowing that and understanding what's allowed, not allowed, that same approach is really important when you're designing an agent. I for one, I'm going to come out. I don't like the word agent. It's like SOA back in the day, or component-oriented software. People are using the word agent for everything. Um, in most cases, it's a service with some thin layer of LLM on it, in it, or around it. But it's still mostly service-oriented software. So you still have to apply all of those best practices that you've learned over the years. So you kind of have to ratchet up that autonomy or lack of control. So you start deterministic, then maybe you add tool calls and MCP servers. And from that, you say, okay, maybe I'll add something in a loop. Now the agent's doing multiple things after it's getting some information back and observing something, then reacting to that. Then maybe at some point you add another call to an agent or LLM. So there's additional non-determinism. Now you kind of have these combinatorial effects. But most business process, in my opinion, don't need to even go to that. Like, you start very simple is like my takeaway for everyone. Start deterministic, start simple, be able to explain your state machine, and follow good DevSecOps practices.
Yeah, that's great. So, kind of unpacking this a little more. Once you have control in place, the next challenge is trust. We touched on that a little bit at the beginning, especially when the AI agents are taking on real actions that affect systems, data, or our customers. So I want to get this question to everyone, but I think I'll start maybe back to you again, Sujan. In high stakes environments, accountability is absolutely, without a doubt, a non-negotiable. So how do organizations ensure that every AI agent action is clearly attributed and auditable without affecting layers of complexity or slowing teams down? What does responsibility autonomy look like in actual practice?
That's a great question. I can't tell you that I have a foolproof answer for that. I think that's still something a lot of organizations are trying to figure out. But for me, I think of it like I mentioned earlier about personas, job descriptions, and who's responsible for what. I don't know why it does those weird reactions. So if you again, so it's almost like a UX, right, for agents. So it's, what is the agent? What exactly is it doing? So like what actions can it take? That's one step. So enumerating the list of actions at a granular level. So then okay, these are the things it can do and these are things it can't do. That kind of becomes a contract. Then you have to tie that back to the overall business transaction and where does the human in the loop fall in that business transaction? So what is it sending or initiating? What action ultimately is the agent doing? Logging all of that. So you have a trace through that entire span of like, okay, the human initiated this transaction, X number of things occurred, agent did this, it was by this user principal, this is the agent with this ID that did that, and logging all of that so that you can trace and answer those questions back as to what was accountable. Now, the actual problem of accountability and who do you point fingers to, that's a much harder problem, and that kind of comes back to organizational culture and like chain of command and a clear hierarchy. So if I'm who's ultimately responsible for the outcome of a decision or making the decision. At the end of the day, they are implicitly or explicitly signing off on an agent being part of that. So that person, that may be several levels removed from the engineer who wrote the code. But that person, that business person, is responsible at the end of the day. So there's accountability to them and to the software, but it can't just be one side. It can't be just the human or just the software. It has to be kind of combined.
Josh, what are your thoughts on that?
Yeah, there's a lot of, just to pull on like, I guess the accountability thread, there's a lot to unpack there. I've been talking with lots of lawyers, um, corporate plaintiffs, SEC, like there's a lot of case law around like if I'm a contractor and I show up in your organization and I do a bad thing, there's case law around that. Like it's if I go to work with Sujan and Sujan tells me to do a thing and I do a bad thing doing what he told me to do, typically Sujan's going to be liable. But if I show up as a contractor and start messing around and deleting things, like typically the contractor is liable. It's not clear when it comes to agents, like who's liable for things. So if I sell you an agent, for example, if you convince my agent to do a bad thing, who is liable? If my agent convinces you to do a bad thing, who is liable? So there's a weird like sycophancy thing where, it's not clear, who's liable. The other challenge that I've seen is I've seen people's jobs be on the line because they'll task the agent with something and, this is a real example, talking to a large publicly traded company, they turned on like Copilot to, search for data. This person searched like, show me all the files written by the CTO. It returned a sensitive M&A document. CTO freaked out. The lawyers got involved. The employee was put on leave. They had to hire a digital forensic analysis. Like, who did this? Did you do this on purpose? Another, talking to large enterprise, like a large bank, like they're very concerned about like the coding agents. So for example, let's say I'm using a coding agent and a vulnerability gets in the code. Okay, Sneak finds it or whatever. But how do I do my investigation? Like, do I have like a human insider threat? Did the agent do it? Like accidentally? Was the agent hijacked? How would I know? Do I believe what the human's telling me that they didn't, so it gets back to what Sujin was saying of having very, very clear like trajectory logs, like every step that, the agent did and what exactly happened, I think is going to be really important for forensic auditability as well as like accountability. And I think that part of what we need to think about as folks building agents is how do we limit liability and how do we put our own, behavioral controls in the agents that we're building that we might sell to someone else, that could do a bad thing. So, you know, there's just a lot of like case law I think that needs to get like solved on that stuff. And so, I that's just the thread that I would pull based on like what Sujan was saying around like accountability and why that like immutable, ledger is going to be so important. Manjit, I don't know if you have any thoughts or Melissa, you want to ask something different?
Yeah, no, that's Angie,
Yeah,
definitely.
Sujan and Josh have covered a lot of ground already. I would just touch on a couple of things. One that has been alluded, which is explainability. The decisions that are being made by the agents, they need to be a way to explain it. So when you're writing it, just be able to prepare that. When we launched our machine learning AI platform at Star for data governance, that was a fundamental question we had, and that was a basic principle that any decisions that are made are not just logged for auditability and forensic investigations, but also we are able to understand it. And so there needs to be enough instrumentation there to do that. It's not just for investigations around incidents, etc., about data breaches. It's a lot deeper than that. The second aspect is this has really worked well for us as we launched our own MLAI platform. And this really kind of making decisions on where do we want humans involved in it, right? And so it really comes down to three levels, right? So how autonomous do you want it to be? The first one was human in the loop. I talked about this at the top of this call, which is really high impact actions. You want a human to be to involved in it initially until you have confidence and you have enough of a track record. But then there are, others where, these are low risk actions, security operations, gets information about users logging in from various locations. That's really kind of analytics that are happening automatically. You can take certain actions around that, right? So that can be automated because your security analyst does that every day anyway. So you probably, if you're running a scaled operation, you probably have seen that use case, perhaps, thousands of times in a year, like we do, and you kind of know what to do. So that's a very predictable thing you can, but what we have implemented, even in that case, is after the actions are taken on a weekly basis, we are reviewing what actions have been taken to understand that the agent is actually doing the things that we expected it to do. And if there's any learnings, either for the humans or for the software engineers to fold back into the software, that's very helpful. And the third one is kind of the middle ground, which is, supervised autonomy, where actions can be taken, but there is some human element, human input that's needed to make that decision. So I think thinking about agents operation and layering that the three layers I talked about: human in the loop, human on the loop, and human after the actions have been taken, has been is really useful. It has proven to be really useful technique for us to have confidence in our own software.
Melissa, if I
Uh,
can interject and add.
yeah, definitely.
So, not to instill fear, but one thing I kind of ask folks not to do when I'm talking to them about AI implementations is, agents can generate code on the fly, right? That's a whole new sort of attack vector through prompt injection, sort of through like code that can self-modify. That can be really powerful. It can also be extremely dangerous. So even if you were to run that code in a sandbox, right? That's what ChatGPT, Claude, Gemini, if you go and run something, ask it something, it can spin up a Docker container or something in a sandbox, run that code with certain permissions and things in place, and then come back with a result. Doing that in an enterprise setting, you have to be really, really, really certain that you have a foolproof DevSecOps kind of infrastructure and security in place that can prevent anything bad from happening. I think it's very hard to actually guarantee that. So that's something that I think people have to be very careful of, is not to allow arbitrary code execution. That's the ultimate in like lack of accountability. I have no idea what got generated. I can't even like have a signed executable or a signed jar or binary because it's code that was never seen before. What do you do in that case? What is that exactly accountable for that? So that's something that unfortunately, I think we're going to see in software systems, but there needs to be some new legalities or language or disclaimers around code that's going to modify itself that way, essentially.
Yeah, thanks for that, Sujan. I just want to make a quick comment. We're likely going to go over the top of the hour. So if those have to jump, we'll make sure you get the recording. We have a lot more to unpack here. So, Josh, from your experience, what design choices make accountability scalable rather than burdensome as agents become more autonomous?
Yeah, I think we've touched on some of this, but like, to hammer this point home, like, and Sujan and Manjeet have hammered it, is just like, identity. We just need to disambiguate the user from the agent. It just needs to be very, very clear. Like, and I think, uh, we have to do that at scale, right? Like, so identity is something that needs to be figured out. Um, there's also like uh, you know, like we've talked about this too, but like I think accountability, scalable, Sujan has been in a really hammering this also in a good way, which is just like, what is that? And Mungie too, but just like, what is that forensic, immutable ledger of like everything that happened? Like you need all that data to be, you know, to make accountability scalable. So you know exactly, the lineage of a decision and who did what. And especially as we head towards agent swarms and multi-agent systems and like I know it seems like it's far away, but like it's already happening with like things like Gastown and other packages where people are building these multi-agent swarms. And so I know it's far, but like we are getting to a place where like Sujan, to your point, like it's not just agents writing code, it's going to be like agents creating agents, right? And so how do you scan software that hasn't been created yet in real time, right? Like and I think that's like the risk that is going to be challenging. Um, uh, so like those are like some of the like how do we think about like making the accountability like scalable rather than burdensome? And I do think that we are going to have to build an abstraction layer over this stuff. Like, we are all going to have to get comfortable with like humans like literally can't be in the loop because of the volume of information that is going to be, created. And we already have teams like Strong DM that are, patterning engineering development with like, no human sees code, right? Like, and I think that's the, engineer that we're rapidly iterating towards where, sort of like the network layer, right? Like no one here is inspecting every single packet coming in and out of their firewall. And they kind of just believe that like when I'm blocking port, whatever, the firewall's doing it. So I think there's like this abstraction layer that will need to be, created to deal with the accountability at scale. And I think a lot more of what we will be dealing with is how do we, you know, and Manji, you kind of touched on this, but like, humans on the loop or like, you know, again, how do the humans, create sort of the deterministic lanes in which the agents can operate to give them the autonomy. And that I think becomes a lot of like the accountability work of that kind of like new infrastructure, um, checking policies, where are things going wrong? Like, I think that all becomes like a new abstraction layer, that, work sort of becomes like, if I'm not writing the code, what am I doing? Right. Like I have to set policies, check on the agents, make sure my swarms are operating the way that they need to. So I think like those are, some of the ways that that we're heading towards to make this stuff like scalable. And, it's not lost on me, you know, that everything that we're talking about is very like hand wavy, like, oh yeah, you just like, use policy as code and like make everything like it's really hard. And I think a lot of folks are like, even, the companies at the tippy tip of the spear, right, are struggling with this stuff because it is really hard to do this. We do need new primitives. We do need new capabilities. So I think Sujan's advice of just like starting simple and then building. The other thing that I will just call out that can be helpful for, I think, just like as we think about scale is, one of the approaches that we're taking is sort of like a deny all and approve. Like, in other words, like instead of like trying to inhibit an agent's autonomy from, like you can do everything and then restrict, sort of like start the other way where it's like forbid all and then add slowly like, okay, you can read, you can read from these places. Now you can write from these places, but default to, if there's no policy, we block it. And I think like if an agent then, builds some new, tool in Bash and tries to run it, then we would recognize that as like a command that's like not explicitly approved or something. So like there's many details there, but like uh those are some of the ways that I think we're going to have to address getting scalable, address like accountability and scalability to make it like not burdensome. I don't know, Manjeet or Sujan, if you have other thoughts, or Melissa, you want to take the conversation in a different direction.
No, just being mindful of time. I want to get kind of more thoughts, and Manjeet, on when we think about, risk and the executive level, unpacking this a little bit more. How does strong governance and accountability frameworks actually reduce operation and security risks instead of becoming the bottlenecks for any innovation or technology projects an organization should want to implement?
Yeah, I think, I kind of view this in two stages. One is when you're deploying a new piece of technology, new set of agents, and, you want to have confidence that this thing actually is giving you the value you want out of it. And then you're using governance as really a control plane, like Josh and Sujan have very well covered, so to establish those guardrails. But then when you're in you're further along, you've got the thing up and running, you kind of understand your initial use case, you got some confidence in certain areas, you kind of then evolve. And at that level, really the thing that's going to get in the way is the lack of automation. All the policies and everything we've just talked about, if it's not automated, trying to do this manually at scale just doesn't work, right? So I think governance also needs to be automated, and that's a point that Josh was just making as he was talking about, right? So because the scale we are operating at is at a different level altogether. Think of it, thousands and tens of thousands and millions, not just like a handful of components. So automation of governance is critical, and that's it's important to establish as you adopt this. The one area that we have not touched on, if I may, Melissa, if I may cover that, is really kind of the data governance piece of it. And everyone says data governance is fundamental to AI governance, but and that's an important point. Uh, if you in the end, the agents are going to be uh, doing their stuff. They're going to be either looking at data that's available within your enterprise or outside of your enterprise. And then they're going to be using services, right? Those are the two major things that they'll be using as inputs. And so if you're going into, deploying your AI agents without having a solid data governance program, if you don't understand where your sensitive data is, if you don't have monitoring on trying to do that at the AI level becomes really, really complex, right? It's just too far removed to have that. So you need to really get your foundations right. And this is on the same lines as Sujan was mentioning about, DevSecOps, right? So your DevOps, really needs to become DevSecOps, and you need to have a really good discipline about, development and deployment practices. And similarly, on an operational side, if you don't have data governance set up, the chance of AI governance getting to a working state is going to be nearly impossible. So I think that's a prerequisite that needs to be looked at.
No, I love that you brought that up because I feel like it's, one step forward, 10 step backs, and one step forward and 5 step backs. And so it's all builds as this builds and this grows. And if we don't have the fundamentals organized at the front end, it makes it more complicated the more the technology moves and the more vendors and people involved in these organizations. And so, Sujan, from engineering and operational perspectives, what technical practices are essential for maintaining confidence in AI agents once they're running in production, especially when the behavior can't be predicted? And what kind of the second piece of that is kind of what separates teams from successfully operationalizing AI agents from those that are actually stalling? I think I've heard some recent numbers that, over 80% of these projects, you know, are failing. So can you help us unpack that a little bit more?
Yeah, absolutely. Um, thanks. So I think to the first part of the question, a lot of that revolves around testing, regression testing, and evaluations. So to have some level of confidence that your software, which has some non-determinism in it now, is going to behave under some percentage of cases, in a certain spectrum of potential responses, um, you have to have very strong regression suites and evaluations that you can run every time something changes, every time a model changes or a model parameter changes or a prompt changes or some tool downstream in the tool chain changes. Any one of those things, back to the point about lineage earlier, can potentially impact what goes into the prompt, which then impacts what comes back out of the model. So having regression suites around that is extremely important. And what that also means is you can actually enumerate the number of things going in it and what potentially could come out, not just like, hey, let's add an LLM, it's summarizing this really well, or it's doing sentiment analysis. And, a few cursory test cases, it looks great. And then you slap it in and say, wow, this was so easy to implement. And now we have this powerful feature. But the minute something changes or something's outside of those few ad hoc test cases that you ran and it was like a feel good, like, oh, wow, this doesn't work reliably. It's not repeatable. Every time I run it, I get something different. That's why having those regression tests are so important and limiting what it can do. So you don't want to just have any set of responses or outputs out of it. You want to constrain it just like you would normal software and have some sort of input and output validation, pre and post checks. So regardless of what comes out of it, it has to fit within a certain shape. That's also the reason why I'm starting to, like I use a lot of Python for many years, but recently getting back more into statically typed languages and TypeScript and Java and other things, because with these coding agents and statically typed languages, I feel that allows me to have more confidence in a certain amount of tests happening at the compiler level before I even go to run it. People are just vibe coding out the wazoo now. So like doing that, adding vibe coding to a dynamically typed language or an interpreted language at runtime, that really scares me. And then to the other part um, of the question, could you repeat the last part again, please?
Yeah, just kind of getting, the organizations that do this successfully, and they operationalize AI agents versus the ones that either stall, fail, dump a bunch of money in the projects and,
Right.
one step forward, 12 step back.
Awesome. Thank you for the refresher. So for that, and obviously it's everything I just said, but it goes back to um, understanding the use case and the value to the business. What's the value proposition? So why a lot of these, in my opinion, fail is because they're trying to, it's a solution looking for a problem. So what actually you're trying to achieve, what is the ROI and the value proposition to your customer or to your business? And you got to kind of work backwards from there to understand, okay, what piece of this can I potentially automate and use AI for that's going to help the overall business transaction? And what we find in a lot of cases, a lot of companies want to use AI, but they don't have their data house in order, right? They don't have a clean data model. They don't have an understanding of their data. It's not well documented. They don't have APIs around it. So you can even do traditional automation. Right? It's like, I need my data centralized, well documented, modeled. I need an API around that so I can produce results. I mean, I can produce utilities or data engineering pipelines or applications on top of that to transform and automate my business. Once you have that in place, you can start adding potentially some non-determinism or AI agents or things like that. But I think a lot of these fail because they're really identifying the value proposition and they're not doing all the necessary things from a data engineering API perspective that have to happen before you can even talk about AI. So it's a lot of, these are boring answers I'm giving. They're not, okay, the latest and greatest like AI using it's because a lot of it is traditional software engineering, data modeling, as Manjeet was saying, data governance, as Josh was saying. Like, so these are all traditional things we need to do anyway. And I think a lot of companies may not be necessarily doing those things. And that's why you're seeing a lot of failed projects.
Yeah, that's great. I love it. Couple of quick, I want to questions that were in the chat, quick answers. Thank you, Rich, for throwing one in there. So, does the layer, let's call it Tron, live adjacent to the firewall? Hashtag fight for the user. Anyone want to chime in on that quickly?
I mean, I kind of responded in the chat, but the layer that I was kind of referring to is just like, these are all semantic layers, right? Like it's all ones and zeros. So like the semantic layer that I'm talking about is this, like, I envision it. It's like this agent space. I don't know another way to call it, but like this agent layer, like while the agents are going their trajectories in motion, like that layer needs to be like, that's the layer that I'm talking about. And it's a semantic layer. Um, uh, I can show charts and stuff, but like I'm not here. But like, Rich, we can always geek out about it later. But that's kind of like the layer that I'm focused on. Is just like while the agents are in motion doing things, how are we making sure that every step that they're taking is according to the rules, and then be able to adjudicate in real time. Is this doing a thing that I want it to do at that like action layer? Like, while it's there's many different layers, and like I really like thinking about like the layers that I have in my head when it comes to like the security are, you've got like this code layer, right? Like I need to make sure my code is secure. You've got this identity layer, right? I need to make sure I know which agent is which. You've got like what I call like a gateway layer, or like like can the agent start the mission? Is it authorized to start the mission? Then you have this layer that's like the configuration layer. Like Sujin's been saying, like every agent, it's still software. So all the posture management, all the stuff that you would use like Wiz for or whatever, like they're going to have buckets and exposed S3, all that stuff. You got to search for that. The layer I'm talking about like kind of sits on all of that trajectory layer of like once the agent's in motion. So if you haven't been noticing, I've been referring to the Waymo a lot here. My favorite agent, because it's like so visceral. But like, if you think of the Waymo, right? Like I got to make sure that the code in the Waymo is secure, that actually like, the Russians haven't infiltrated it and like done things. Two, I have to know identity, which Waymo is which. Every Waymo needs an identity. I know which one's doing what. Three, like orchestration/gateway. I need to know, is the Waymo allowed to leave the garage and start the mission, right? Fourth, configuration. Is the Waymo's like air tire pressure good? Is the battery charged? Do the windshield wipers work? Like all that configuration needs to be secure. But then once it's on the road and driving around, that's that trajectory layer of like, how am I in real time making sure that with provable controls that I can go to regulators and be like, yep, every time our Waymo is going to stop at a red light, not, well, there's a 1% chance, but we're working on the model and it's going to be better. And like, whatever, like, that doesn't satisfy business or regulators, right? I need certainty that it's going to always stop at a red light. And if it doesn't, there's a control that can be created and added, not, well, we're going to like retrain the model again. And like, hopefully, it won't do that again, right? Like we need provable controls. So those are like the different semantic layers that I have in my head when it comes to how do we, secure these agents. They're semantics, so you can make up your own too.
It makes sense.
Yeah.
Makes sense. A couple more quick questions. How do you, just really quick, we're packed for time here, but how do you design and systemize evaluation methodologies with agentic security scaffolding in mind, where business incentives, goals, and even quantitative system telemetry is non-existent, or when business guys think they know what they want, but they really don't know what they want? Touche, right? Thank you for that question, Tony. Anybody else want to answer that one?
Throw that in an LLM first. That's a long question. I'm joking.
Yeah. Tony, I answered like kind of in the chat, but just like, what Tony's getting at is a real challenge for, I think, all the industry, which is like evals, right? Like how, like everyone knows, like, all the models like game their evals, right? Anthropic sets the evals for Opus 4.6, beating every other model on the eval. Oh, what a surprise. So we don't really have like, institutionalized third party like evals, like what does good look like for an agent? And I think that is something that's really tricky. You have a lot of companies now that are focused on some of that aspect, like, ranges and, creating heuristics and benchmarks and stuff like that. So I think that's tricky. Like we don't have a baseline yet of like the EU AI Act says you must hit this benchmark in an eval. Like that doesn't exist yet. Um, that will be something that I think, Sujan, you've hit on, and I've talked about it also, but just like simulation and having that evaluation ahead of time as best that you can to show reasonable care, a standard of care that you're like testing the agent ahead of time for what can go wrong. And at least have some type of eval. And then for the business guys thinking they know what they want, like I said, like that already exists pre-agent. Like that's like that. We already have that problem. But I do think that agents can help, suss out like for the business guys what they're really thinking and what we might. But those are just my like raw thoughts on that one. I don't know if Sujan or Manjeet have other thoughts.
I mean, I think generally speaking, from my perspective, the last point you made, Josh, is kind of what I was going to say. Like, a lot of these problems existed before this stuff, right? So, not knowing what they may want or not understanding how the incentives and the business value proposition aligns with, like we're saying, like, hey, we want to constrain what the agent can do, but the business wants X, Y, and Z. So this is where I go back to my ratcheting it up from like a fully deterministic state machine driven solution to more and more non-determinism. Is you start on that left side with very little non-determinism or no AI, and then you ratchet it up, because as long as the business is getting their value proposition, and doesn't necessarily mean there has to be AI in the solution, right? Or that AI has to encompass the entire solution. We're all smart people. We're smart engineers. We can figure out how to solve a lot of these problems, maybe get 85% of the cases through deterministic engineering. Generally speaking, that sort of metric is great for a business when they're meeting most of their customers' demands. So then figuring out what that 15 or 20% you can't meet, where you may need non-determinism, and then building very specific cases for that, and then testing that, I think can reduce the amount of testing that has to be done on the non-deterministic part, while still meeting business goals. Because right now everyone's hearing AI, right? And my brother-in-law told me, won't mention the company name, but they're using a piece of software internally where it has like .ai at the end of it from an internal marketing perspective. But he goes, there's actually no AI in the software at all. But that's how the software is being sold internally, so people use it. So you're seeing businesses go after AI even when AI is not part of the solution, purely because it's a zeitgeist right now. So I think we can take that to our advantage and say, okay, hey, this is AI. There's an agent here, and maybe 90% of it is not necessarily an AI or agent. It doesn't need to be, but it meets all the requirements. And that 110%, whatever, you can try it out and use it. So it doesn't really answer like, what do they don't know what they want. That's an age old, tale as old as time, that AI is not going to potentially solve, but using AI can help you potentially evaluate a lot more options and become more educated. So I'm finding that just being able to use things like LLMs like ChatGPT or Claude is a superpower from the perspective of learning a topic more deeply if I want. Explaining it to me like I'm a 5-year-old, or learning at my own pace. It doesn't chastise me for asking the same question 50 million times. So use it as this powerful tool to learn and grow. And I think we can all become more knowledgeable about our customers and our business, and like learn together, which I
I
feel
like that.
for AI, that was harder. AI can allow the engineer and the business person kind of even collaborate more closely.
Yeah, that's great. I think kind of to round the corner, to hammer it home, to put the cherry on top, quickly, Josh. We'll start with Manjeet, though. Let's just get kind of any final thoughts or anything that you want to leave with our listeners that we didn't touch on today. Any quick thoughts? Manjeet, start with you.
No, we've covered a lot. We have talked about developing agents to operational agents, and it's a broad topic. But if you want to reach out to any of us after this session to have a deeper discussion about your specific area, please do reach out to us. I'm sure you'll get our contact information as part of this session.
Thanks for that.
Like,
Josh, any final thoughts? Give us the home run,
Oh yeah,
grand slam.
well, whatever. I dropped my LinkedIn in there. Feel free, anyone, to connect with me. Like if you're building agents and want to geek out about this stuff, and always happy to chat. I would just say that like, I probably everyone on the call here is already like, AI pilled and all that stuff. But like, I do feel like, there are folk like we kind of talked about like, oh, like the MIT report, 90% of all the, projects fail and this, that, and the other. Like anyone, like, how can I say it? Like this technology is transformational. It's going to change everything. Like I really fundamentally believe that. I think I don't think engineers are going to tell their managers that they can do 1 day of work now and it's really 5 days of work using like Claude code. So I think, how effective is AI gets underreported, right? Because you can do so much more in a day. And then the other piece of that is I feel like it's such a fundamental technology. It's like asking someone like, can you quantify the ROI of like the internet for your business? No. How do I know? I don't know. I just know that I couldn't do my business without it, Like, so I feel like the ROI is manifest and will be more manifest. But like, what's tricky is like, it is a hype machine, but I also feel like it's overhyped and underhyped. The end. All right. We can talk more about it. Go ahead, Sujan. Take us home with something more pithy
No,
and
I don't think I have anything more thinking that, but to the take home is not even necessarily agents, but since those who are here, so is, if you're not utilizing AI, start using it. And it's not a matter of like using it in production or deploying it in production. It's using it to extend yourself, to learn, to grow, to do more things at once. It requires a mindset shift, but I feel like that mindset shift occurs the more and more you use it. Um, I know people that are kind of skeptical to using it, and you should be a skeptic. I think that the people that get the best output out of AI are skeptical, and therefore they're very detail oriented. They ask the same thing many different ways. They do it iteratively in thin slices. They're not just like, hey, YOLO vibe code this whole thing and vomit it out. But using it, you can learn a lot. You can do a lot. You can see other people's pain points. It's sort of like VR in that sense. Like I can put this VR headset on and see through someone else's perspective. And I feel like AI allows you to do that from many perspectives. So please try it. If you're on the fence, reach out to me. Anybody, I'd love to chat with you and talk to you about software development, AI, agents, etc. Like I tell people, AI, if you're a math person, right? AI is not an inflection point, it's a discontinuity. It's scary. So think about that if you know calculus. But it's really going to change a lot of things. So really just try it out if you're on the fence.
and
And I love that you said that because I was gonna close home with that. I think that's the key, Sujan, is just trying it out and then kinda to piggyback off what you said, I think a lot of times I'll use one tool and plug in a different tool and see what the outcomes are. And I must be one of those skeptics you're talking about because the answers are not often the same. But what we've heard today is that successful AI agents isn't about choosing between innovation and control, but it's about designing systems where the two reinforce each other. Control, logic go onto the systems, not just the prompts. Accountability needs to be automatic, but not just manual. And trust is built through architecture, governance, and visibility. So I want to thank you three for being here today and sharing your insights and your stories and your jokes. And thank you all who joined us today. And thank you for your patience with our late join. Tracy has put in the chat that she'll get the recording out to everyone. And as everybody on the panel said today, feel free to reach out. They love to geek out, to chat more. And that's it for me, Tracy. Anything you want to close with?
Let's see. There's a couple. Oh, Sujan, you saw the question from Rowan. So maybe we can get that answered offline. Thanks, everyone. Thanks for everyone's patience and joining us and staying through, us being a little bit late. So stay tuned for more webinars coming your way from Chariot Solutions.
Thanks so much, Tracy.
thanks everyone for hanging out.
Yeah, thanks everyone for your patience. It's awesome.
Bye bye.